Okay. All right, audio check. 1, 2, 3. Okay, not too bad. I think that's good enough to get started. So let's get started. Okay, we are laying things out in the sandbox. So when we go do the final art, everything will align perfectly. So that's the goal and the plan. We have notebooks on tables. We have chalkboards with chalky looking letters. We have a banner with permanent marker looking letters on it. I don't like this beige background or this blue floor. I need to find an interior decorator or something. Let's see here. If I just look at some images, get an idea. See, all these are ugly. Why do we have such ugly schools? The floor is white. Although the walls are white. The floor tends to be wood, but I've got like bookcases and tables. I don't want to overdo the wood. Maybe. And I don't know. I'm just looking at ideas while we're warming up here. That one has blue floors. Hmm. Yeah, why is it? This is more maybe of a philosophical question. But why do we associate children with ugly things? Like, I've noticed this in children's books too. There are very, very few children's books that are illustrated by a great artist. Like Jan Brett is one of the few who consistently turns out a beautifully illustrated book for children. Or there's a book I remember from when I was a kid, a couple of different Christmas books that were just absolutely beautiful oil painting art, all in them. It's just huge, beautiful art pictures for kids. And I'd sit and stare at those things for hours. But I don't know, people think that kids need something stupid, dumbed down, lame, stick figure outlines. So no wonder modern aesthetics have died. You dumb things down for kids, you make dumb kids. Kids get smart by trying to keep up. Anyway, mini rant over. So, our schoolroom, we can change the carpet color a little bit. The wall color, I don't really like it. Maybe we do. Let's just play around with a little bit of colors here for a minute. So our clear color right now is a beige. Let's just try a really, really light blue. Like, I don't know. On the carpet, let's see here. M_floor set color. This is a very dark blue, but I don't even think we want a blue. Like a green, a lighter green. So maybe 92. I don't know. We'll just try it. We're just warming up. So is my computer, apparently. Oh, it's the image warehouse. I must have re-embedded the images. Of these unused variables, I don't think we need this one. I don't think we need that one. I don't think we need this one. I think we just need the V spacing. We'll just remove those so that I'm not polluting my output. We'll have to come back eventually and use the shelf word spacing, but I don't need it. Why clutter my code and have clutter in my output? So then the other thing would be in the layout math. And we won't delete it, we will comment it out. Okay, so just a little comment out. Hey JTL, doing good today. How are you doing? Gotta get some onions and peppers tomorrow for fajitas. I think I'm gonna make the fajitas a bit on the spicy side. Looks like it's mostly chili powder, paprika, cumin. Yeah, this all looks fairly standard stuff. What can I bring? I don't know. I'm thinking the kids will do hot dogs and s'mores. Chicken? Oh, chicken's good. Yeah, I was gonna bring a couple of steaks, but I mean, if we want to add some chicken to the mix, that'd be great. Sure. We can do 2 Dutch ovens of fajitas. Yeah, if you want to bring a couple of chicken, that would be great. That blue does not look very blue. I need to remove some of that red. That green could be a little darker. I don't want it to be this same green. Art is hard. Or maybe nobody's explained it to me in a way that I can relate to. So 164, we're just gonna make that a little bit less pale. 92. Floor. 64, 32, 8. We'll just see how that goes. Awesome. Yeah. We're just playing with colors while I wake up my poor brain. colors is not right now my main concern. It's mostly the layout. But that beige was the same color as the front of these tiles, so I just couldn't do that. And now the banner stands out better with that off-white paper. Okay. I think that reads a little better. I think this table color is terrible. These two browns are too similar. Well, yeah. Whatever. We'll fix that up later. Just getting things close. I can't really afford to move the table though with those books that big. Okay. All right, so let's get started. All right. I don't know about those. But I suspect what we'll have to do is break up the bookshelf. I suspect. So that's our plan today, sort of. Right now the books don't look very. It's all very 2D, very flat. No depth to them. They're all the same as well. We probably need to generate several different bookshelf options for ourselves. So that brings us to layout math. Here's a notebook, and actually there's going to be a lot of similarities here. This is not a notebook, this will be a book set. The page colors can be the same, I'm fine with that. Oof, all these colors though. Let's just start with blue. And we'll circle back around to colors in a bit. Spacing between books. Okay. So the simplest thing to do for us is what? Blah, blah, blah. So that's the spine. We could go up from there. Might look something like that. So we have the left cover, the right cover, which can be the same rectangle, just shift it over. And then the spine. Then we need the pages. So it'll be left, pages, right, spine. I think that's the plan. We're going to check spacing for now. bookshelf has a depth. And that depth is 105. So our book should be narrower than that. Left cover, pages, right cover, then spine. That's the order we have to draw those in to make it work. Cover depth needs to be, let's just throw something there, 75. We're gonna make this semi-randomized in a minute, as well as the colors, but we're just gonna get a book on the screen that looks okay. This is not relative to a table at all. For cover width, we're gonna start with a fixed number. 4? Of course, now I can't remember. 8? Yeah, so these are smaller books. The cover height. So the shelf height, which should be in bookshelf, it's not very high. And, oh no. So we have the shelf thickness, which is the actual wood that the books are going to sit on. Yeah, we need to completely redo bookshelf here shortly, but I just want some numbers out of here, such as def shelf opening width doesn't matter, shelf opening height. You want to use those down below. Now, how do we calculate those? Computed height. We have characters wide per column. Pretty sure that's the number that matters. Yeah, it never shows up here. Okay, well, we know the computed width. Which is really this plus some word horizontal spacings. So I think it's just the opening width is the block size plus 2 times the horizontal spacing on either side of the blocks. So that's the size of the opening of a shelf. The shelf opening height is basically the block size plus the word spacing. Shelf top thickness, yeah. I think it's roughly that. Okay. So if we were trying to analyze the book set, and we're gonna make tons of books today just to see what we can come up with. So we need to get one on up first. We get our standard block, we get our bookshelf. Then we can ask shelf.get opening, shelf opening with O. Shelf width and the shelf height. Those will be important. The bookshelf takes a block as input. Okay. So the pages have a width and a height. No, I don't actually want to output anything. We're just gonna do this. Nope. We're gonna nope debug this. Nope development. Basically means I haven't actually implemented this yet. But we are going to print out our shelf size. Shelf opening. Because later on for random number generation, we will be using that quite a bit. Also, I need to know kind of what the maximum is. Okay. Sort of be in here a little bit, dot slash, layout math, I, or a book set. Block. Okay. I think it's called a letter block. Oh dear. Dot size. Did I delete that? That would be very foolish of me. Huh. We did. How would we do that? Nope. It's gone. Okay. I'm gonna have to go back into Git. Let's get the last four. Where are we at? Notebooks are in sandbox, so they're better. Tables laid out, better method for Inkscape scripts. So this is the commit that broke us. If we check out this one, or if we git diff this one. Oh, dang it. Shoot.
Yeah, I didn't even touch you. No, I did not. You threw yourself up. I never touched you.
Okay. So this is unfortunate. This is one of the things I actually don't like about Emacs. This should not take so long. Even rendering out hundreds of thousands of lines of text should not take this long. It is not good with large buffers. Oh, come on. Okay. Alright, so git stash. So what we're going to do is we're going to git stash. That takes these unstaged changes and puts them somewhere out of sight. So it'll look like our stuff is clean. Then we're going to check out this one. Then we go to our layout math.py, reload it. Those are the old commits, so layout. Looking for letter block. Okay, now we check out master again. Git stash top. So it takes the thing on the top of the stash and puts it back where it was. And now when we go to layout math, letter block, we can put this back in. ISO width and height, and everything else should be the same. So I think we are good to go back where we were. This one. Hey, now it opened. Now it works. So according to theory, our shelf opening is 403 pixels by 790 pixels, which we can verify by looking at Gimp by care2. Put a couple of guidelines in and just do a little subtraction here. Let me just verify. I'm like 99% sure it sounds about right. So I've got with the calculator, I've got 424 and 19 or so. So 405-ish. 403. Yeah, I can believe that my mouse is not being positioned that carefully. That's the width. That is not the right shelf opening height, though. Not even close. Let me do a quick measure there, so we know what number we should be getting. This is basically the maximum height for our books, right? So if we go with like a 92, oh, let's see, not a 92, a 172 minus 92. 172 minus 92 is 80. Okay. So in theory, I'm fine with this one. I'm not fine with this one, but this one, so your opening height. Oh, we only want it for one word row. That actually simplifies things quite a lot. Much better. Okay, 79, 80, yeah, okay. So I can believe that. I'm fine with that. Okay. So our maximum height for a book is 79, and our maximum width for all the books is 403. Okay. Okay, so we're gonna do that. Comment that out for now. Okay. So page height. We just want a page offset, I think. Cover width. Right. Cover height is basically the height of the whole book at this point. So I said it was this for the reference. For the height, let's make it 75 tall. The depth. Oh man, let's see here. Bookshelf maximum depth is 105. Bookshelf depth. Actually, we can query that ourselves, but that's okay. 0.3 float modulus shelf depth in pixels, which is this. That is our theoretical maximum here. When we do the, here's a question. So that's the first shelf. How much is our shelf ISO? Shelf height. Extrude width, extrude height. Hmm. Okay. Yeah, we definitely need to refactor bookshelf here eventually. All right, so just run this real quick. Make sure the depth is 105. Book set. Shelf. There we go. Not stealth. Shelf. Yeah, 105. Okay, perfect. So we have those numbers in our pocket. For covered depth, can be at most 105, so we'll go 100. Page offset. Well, sure, why not? Cover width. Okay. Okay, we're just going to stick with some hard-coded numbers to start with. Here, we're going to do that. So here's a fun little tidbit. Maybe we should, um, hmm, okay, so two ways to do this. Blah, blah, blah. So what I'm thinking is we need to, let me put this in the old chat so you can follow along in the documents if you're interested. RGB, while I tend to work in RGB, it's not always the best. Sometimes what you want is hue, saturation, and brightness. Hue is actually kind of interesting. I have a different project where I actually did a little bit of looking things up, but so I'm looking at hue. If I can convert my RGB value to a hue, if C is 0, hue is 60 degrees crossed with So basically I would like to take one color and make it lighter or darker. Arithmetic mean, hexagonal pyramid. Luma. Hue, saturation, brightness, HSB. So here's the thing. We want to, ideally, and we'll come back around to this. Ideally, we'll get one random color for each book, and then we'll compute the light and the dark from that. So HSV is the thing we might want to deal with. So let's see here. Let's write down just so we can keep track. Randomize book sizes, randomize book colors, hue. Where is this bookmark here? Color conversion. From RGB. I think this is the link I want. To do allow runs. To do books at angles. Books lying flat in stacks. Okay. All right. These are all different things we might want to do. In the meantime, we're going to say the following. That all's going to go away. Spine. We'll just start with spine. And draw a cube. Now what we're going to do is draw it from Dravest. How's it going today? So far, so good. We are going to put books on bookshelves today. I got my workout all done. Got an omelet in my belly. Drinking my yerba mate. If you're from Argentina, yerba mate. And yeah, life is good. Sunny weather out there. It's warmer today than it was the last couple days, so that's nice. Okay. So for now, we're just going to go 0, 0. Cover height. Cover width. And depth divided by 2. So that should draw a vertical spine in theory. Sounds nice. Yep, it's good to have a good routine. It's good to have a good routine. How are you doing, Dravest? What's new? You know what? I'm going to stop doing this for a minute. Just show, draw a cube from 0 to 0, 75 width, height, depth. So that's probably not right. So there's the spine. Width, height, depth. Okay, I think that's good. You want the left cover. This one will be cover depth, wide, because it's putting in the screen. The height is the same. And the depth in this case is the width. Depth, height. Oh, no, 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 no. Width, height, depth. Width. Okay. So I'm thinking about this wrong. The width is this. The spine in this case is cover width times 2 x, y, width. It's the page width. And then the cover height and the cover width. more than one cover width. We go page width, cover height, and the cover width divided by 2. The left cover is our width, height, and depth. And the right cover is a clone. The left cover with the transform equal to translate some amount and it's basically something we can do right now. It's self.page width. Okay, then we group it. Book equals group. And I said we're going to do left, then pages, then right, then spine. So group, left cover, right cover, and the spine. Okay, see what happens on the strings. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Oh yeah. You're offset. There we go. Okay, so left cover, right cover, spine. Okay. Translate 16. Okay. So it's Wednesday. Everybody's halfway done with their week. That's always nice. I've got blue. Okay. We're just gonna hard code that for now. Take a light color equals light. Let's cover color. Okay, so that should crank out. The book. Or to be more illustrative. Thusly. Not sure if that clarifies or just makes it worse. those are those lines. Then this one. I think that's a little more readable. There, something like that. That's a little bit clearer, I think. Okay. All right, let's crank that out. Okay. Now put this to temp.5. Then we can see how it looks in Inkscape. Here we are. Okay. That was a book we were drawn yesterday. Now we run it. Takes a little while to warm up the old Python first thing in the morning. Nope, it doesn't like nope. Okay. All right. I'm not gonna lie, that book is very, very deep for how short it is, which is fine. So let's go make an adjustment to our script. Make it 50. 75 is about as high as I'm willing to go for our maximum height. Cover width, page width, etc. Okay. Let's just see how it looks. Yeah, I think that's about as deep as I want any book to go. Okay, so let's throw in over here the pages. And here is the trick. Pages have to be offset. Cover width, I think. Cover width is 8 pixels, yeah. Actually can't see much of the page. These two sides should be hidden. Okay. Yeah, the only thing visible should be the top face. So actually this is front. Top. Right. Okay. So the colors we're doing things in. Where we want to start is inset from the spot. So we need to, well, let's see, here's cover width. So we're coming over this, the width of the left cover. And then we're shifting over the height to make it inset a little bit. Zero plus the amount we need to move it up, get off the spine. The width of our book is now self._page width. The height of our pages. Oh, that's true. We need to move it. Some amount inward. Cover width minus that. So if we want to drop the whole thing down, so then self dot cover height minus 2 times self dot cover width. If I'm thinking through the problem correctly. Left spine page, left pages, right spine. All right, let's try this. It does not like my syntax. 689, 60. What? Clone. Left, right, width, height, depth. The depth is our cover depth minus basically that. So what is the invalid syntax? Supposed to be print. Oh, we need another parentheses there. There we go. I do not see the pages. There they are. Are they just too short? Yeah, just too short. So for thinner books and thinner covers, which kind of makes sense. Okay, so it's showing, and it's even showing sort of where we expect, except let's make it closer to the actual size. Like half the cover width. Okay, there's a book. And the pages do show up, even if the book is a little bit on the narrow side. Okay. But now we should be able to randomize a whole bunch of these books, in theory. So let's see if we ungroup. Can we hide? Is that a thing? Let's just delete it. Okay. I think that's a reasonable book layout. So now we get to the randomization part, which is actually kind of the fun part. So we have some parameters: cover width, height, depth, page width. I think that's about it. So we've got, oh, the page offs. Oops. We didn't actually use that. Anywhere. And it's fine. I don't think we need it. We really only have 4 parameters to speak of. Hmm. Page width min equals 12 pixels is a pretty narrow book. Page width max. From 12 to, I don't know, 32. That's a fat book. Cover width range. I think 8 is about as high as I wanted to go. 4 to 8. Maybe. Okay, cover height. Max of 75. Minimum? I don't know. 25? GHB. Okay, depth. Maximum of 50, minimum of, yeah, 25, sure. So if we make the smallest book possible, page width range, cover width range, height. Look like the smallest book we can. We can make that depth smaller. It's the minimum depth. Okay. That is the smallest book we can make. It needs to be reasonably visible even at smaller sizes. So let's try the biggest book we can make. And we just take the maximum, which is 1. And there's our big book. Little book, big book. We can make the page width smaller, I think. No. No, it needs to scale out quite a lot. Because our smallest screen is 1024 by 768 that we allow. So I think that might be about it. That's the biggest book and the smallest book. Okay, let's randomize now. Write random book. Page width equals. Oh, I guess I need Python randomness here. Let's just go to Emacs mode here for a minute. There's like a random.next.rand range. Hmm. Hmm. Not seed. Oh, let's see here for sequences. Shuffle is probably a thing. Discrete distributions. Random.uniform from A to B. Okay. can circle back around to colors here in a minute. This all goes in here. Okay. Okay. Now, the shelf opening height, we need to shift everything down by that much. But it's all the same everywhere. So I'm going to do colors here. We can print shelf opening y offset equals self dot shelf height, right here. Plus shelf height on all the y terms. I should put the bottoms of all the books at the same level. I don't have to make any changes anywhere, in theory. Okay. Write a random book. Except it has no shelf height. Okay. Just a moment. Okay. So, theory, this should make a random book. Of course it doesn't. Shelf height is not defined. Oh. Right, try it again. Boom. There is a book. Right there. Okay, now we need to generate multiple books. So we're going to come over to the script. This is where the magic starts to happen. Oh, wait, you didn't see that. Okay, well, yeah, whatever. We'll fix it later. We'll fix it in post, right? We need an X offset. Then we need to also specify how far to move over, which is page plus cover width. Return page width plus 2 times cover width. Let's write out 3 books. Then we need to remember to change it so that you can see what I'm doing over here. Okay. Now when we apply, we should get that align the top edges, not the bottom edges. This front edge here. Which is close, very close. But we want the bottoms of these books to be at this line here. So we have to subtract the height of the book up. Easy peasy. Y minus cover height. Okay. Boom. There we go. There's more space in between these books than I would have thought. So where's that space coming from? Oops, not that. Oh, well. Okay. Page width plus double cover width. The left cover is cover width wide. The right cover is also cover width wide. And the pages are page width wide. So the spine, yeah. This mathematically looks right to me, but you know. Just experiment a little bit. Okay, now they're all perfectly aligned. Okay, so one thing we might want to do is add a book set equals group the books. Okay. Let's take a look at this and rerun it. 1, 2, 3. There's 3 books. And yeah, they're a little bit different. So one thing we want to do is have them slightly staggered in depth, as though somebody pushed some of them back too far. That will help them pop a little bit. We could separate them all by like 2 pixels. Different options. Let's just take a look at a couple of those options. So +2, +2, +2. We don't want to put too much space in between them. Later on, art will actually have like curved spine, etc. So that's one thing we could do is just add a tiny offset. The other thing we might want to do, let's see here. Book offset x equals, so width of some random number, random dot uniform between 0 and, I don't know, maybe instead of 4 pixels. Book offset is some amount. Okay, so x offset plus book offset x. Okay. Then the y minus book offset y. Okay. Okay, so we're trying 2 different things at once, which is usually not a great way to engineer a thing, but there's now a bit of a breakup between things. I'm not sure I want that 2 pixel space there. Mostly I want bookshelves to be full. Where do we do that? +2. Let's get rid of that. Okay. That's not too bad. Let's get some color variety in here. And that's where the color theory becomes important from that link we looked at earlier. Okay, so we've got book sizes randomized. Randomize the book colors. Oh. Okay. Okay. Randomizing colors. Let's do a little bit of reading on that. So if we have an RGB value, we can convert it so a hue, let's go look at what a hue is. It's a cylindrical color mapping. So if you look at RGB, it's a cube, right? One corner is red 0, one corner is blue 0, one corner is green 0. And as you move in an axis, those go from 0 to 1 on those 3 axes. Hue is a cylindrical. So if we choose a random hue, that makes it book that hue, could be fun. Deriving a hue in terms of RGB, blah, blah, blah. We don't really want that. There are, of course, other color systems like, yeah, but hue, if I just get a random hue of 1, go from 0 to 1, we take the brightness at like 0.5, and then we randomly, not randomly, I don't know. There's different ways we could do this. So let's just get a random hue for each book. I think that's the plan. Hue equals random dot uniform dot yeah, sure, random. That should give me a 0 to 1. So our random, we do want some books to be brighter than others. So maybe we choose a brightness that is between like, I don't know, 0 0.35, 0 0.65. Our saturation, we're going to keep it high. Saturation equals random.uniform, like 0 0.75 and 1. Okay. Then we want the following. Oh, random book. I need an index. And we're going to have to insert this color so that this will work. Color name equals book thing This is why we have the index now. Print color light underscore thing equals hash modulus 0x2 3 different times 2 3. Light color equals this thing. And so at the light, we want the mid and then dark color. Then we shove it into the color palette. We've already got mid, light, and dark now defined. Okay, so I lay out the colors. Light, mid, and dark. Okay. So we have hue saturation and mid brightness. Light brightness will get a mid brightness times 0. No, 1 point, let's see, 0.65, 1.25, and a dark brightness. So going up 25%, we want to come down 25%, 0.75. Okay. So the real question becomes, we need to make the red, green, and blue values given the HSV. So that means going back to RGB. Which they don't have pseudocode for. I don't have pseudocode for that. All right, so first we compute They're using L for lightness. Then you find a point along the bottom three faces of the RGB cube with the same hue and chroma as our color, using the intermediate value X for the second largest component of this color. What is this H divided by 60 degrees? Oh, hue is in degrees? I mean, I'm fine with that. Okay, what I'm looking at is this thing. Let me... 2 RGB. Let me see, is there a good way for me to lay this out where I can see what I need to see to do this? Okay. Let's make a small local function, def hue, saturation, lightness, 2 RGB. It will take a hue, a saturation, and a lightness, and it will return the string itself, which is 0x, 2x, 3 times 1, 2, 3 of RGB. Okay, so we're going to compute our chroma equals 1 minus the absolute value of 2 times our lightness minus 1 times S sub L. Saturation. Oh, saturation. Isn't it saturation? Times saturation. Where we get our hue. Uniform from 0 to 360. Okay, so that's our chroma. Then we find the point, so we want hue prime equals our hue divided by 60 degrees, X, intermediate value for the second largest component. So X equals our chroma times 1 minus the absolute value of H prime modulus 2 minus 1. I think that is it. The notation, the notation H prime mod 2 refers to the remainder of the Euclidean division. H prime is not necessarily an integer, so that should be fine. Okay. Then, if 0 is less than H prime, and H prime is less than 1, two, three, four, five, 6. We have 6 options, depending on which quadrant we're in. If it's between 1 and 2, or 2 and 3, 3 and 4, 3, 4, 5, 4, 5, 6. Then we get red equals chroma, green equals X. Then go with R equals 0, GB, RGB equals 0. Okay, if it's this one, it's red equals X, green equals chroma, green equals chroma, blue equals X. So the chroma is the closest actual primary color to the hue we've selected. So we're taking that cylindrical coordinate and saying where on the bottom face of the RGB cube, which color inside there is the closest, the biggest contributor to this total value. Then this X says when we go up, what puts us in the right plane on that cylinder. So it's basically saying what's the second most important RGB value that contributes to this hue. And then the third one is basically factored out. It doesn't matter, it's a 0 by default. So that's what we're doing, is we're saying red was the closest, and here's how much red it takes to get closest. Green is the second largest contributor, and X is the closest green value that gets us there, et cetera, et cetera. So that's, and it depends on which sixth of the circle we're in. So that's kind of what's going on here. So for between 3 and 4, then green equals X, blue equals chroma. For 4 and 5, then red equals X. Oops. Red equals X. Blue equals chroma. And here red equals chroma, and blue equals X. Okay, then we add a lightness term to all 3 of them to move us out into the correct color. Blah, blah, blah. Finally, we can find RGB by adding the same amount to each component to match the lightness. So M is the lightness correction factor equals our lightness minus chroma over 2. That's the correction factor. So we just take R plus M, G plus M, and blue plus M. Where we cast them all as integers. Oh, let's do it here. R equals the integer of R plus M. And I think these are supposed to be between 0 and 1. So I think we have to multiply by 255 GB. And this just becomes RGB again, because you're doing calculation outside this statement. Okay. So in theory, we can now do HSL to RGB. HSL to RGB of our hue, our light saturate light, okay. Saturation, and our light brightness. Comma, parentheses, parentheses. Okay, so that should be just about it. Instead of light, we go mid and dark. That's basically it, I think. Now, how close is this? I don't know. Let's take a look. Let's see if it even outputs something sane. Oh, and. Oh, shame on me. I should know better. It's actually one of the things I really like about Python is that the binary and the logical Boolean operators are significantly different. I like that the Boolean operators are English words. Okay, so let's take a look at temp. Actually, we haven't looked at it in a while. So these blue ones are going to go away. But what we've told it is book 0 has, oh, that's not a dark. Oops. These need to be strings, and that's a negative. So that's close, but no cigar. We draw the left, the page to the right, the spine of the book, and then we throw that into our list of books. Okay, so this is actually close. Good thing we looked at it first. So blue needs to go away. We're not using this blue anymore. Okay. Dark. Quote. String. I suppose we could clamp if we wanted to, but I would like to know what that negative number was about. Let's take a look at our code. Light, mid, dark. 85, D7, -3. So what is it about the darkness? Maybe not multiply, maybe we need to add. Brightness plus some amount. So blah 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 0.25, and then here we just subtract -0.25 and just call it good. Oh, huh. These numbers are not correct. And it's very possible that that's an easy thing to change and fix. All right, let's try this. HSL 0.3 F 0.3 F 2.3 F becomes RGB 3 F. That's the base color. I do wonder. Hmm. Actually, value of all of that. 1 minus that. Maybe I need to do like an F mod. Let's see, in Python, mod, is that in the math library? Should have built in. Math dot, okay. Okay, so that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This has way too many digits. Oh, Wikipedia. Remainder of the Euclidean division, blah, blah, blah. Hmm. Hmm.
Just roll it for Judy. Let's see.
Hmm. So we're getting some strange colors here. So why don't we print these out then? Okay. HSL. 2 RGB. HSL RGB. Let's just see which terms are off. Maybe it's just one term we have a typo in. And there's no way this is gonna work out well for us. We kind of don't care. So temp.phi. Huh. Our HSL. Oh yeah, because we're making 3 per book. So 970, and there's an HSL. So those all look okay. There's a -1 there. Huh. This is greater than 255, so that's unfortunate. Up here, this one's more than 255. This one is negative. Well, shoot. Does the red look okay? I mean, I guess. The green almost looks okay. Like this is close. I don't know. Do we have any color experts in the chat? So a hue of 0 is red and hues near 300 are like a mauve. So lots of red, lots of blue. Did they have a table somewhere? Somewhere I thought there was like a table I could look at. Oh, well. Okay. Maybe we need Python fabs, math.fabs. Maybe that's our problem. So that is a hue of 54-ish. Oh, for Pete's sake. So that should be a yellowish color. Point 0 minus the absolute value of 2 times the lightness. Chroma equals 1 minus the absolute value of 2 times our lightness minus 1 all times our saturation. Q prime divides us into the circle to figure out where we are in the circle. Then 8x is our chroma times 1 minus fabs of f mod 2 of h prime minus 1, parentheses is the fabs. M is L lightness minus chroma over 2. According to Wikipedia, this looks about right. I'm getting the wrong values. In that the chroma or the X are negative. Oh, we could look at what M is. So let's say chroma X M. There's our HSL, there's our RGB. We want chroma X M. M Yeah, that's a negative number, and this is a huge offset. It's more than half. Which is why this number is overflowing, or 255. Okay. Color should not be this hard. I don't want to cheat and clamp. But we can just to see what happens. Because I think mathematically this should work out. Maybe F mod is the wrong operation. Let's try this one more thing. After that, I'm starting to run out of ideas. F mod, not run out of ideas. We can, there's always something else we can do, but we can take H prime minus H prime over 2 cast as an integer. Which is basically what I think fmod should be doing anyways, so it shouldn't make a difference. Yeah, we're still getting negative numbers. Well, maybe we just clamp for now, just to see the effect. How's that? And then we go back to figure out what we did wrong. I don't think this made a difference, so we can go back to fmod. Still seems a little odd. Oh well. If r is less than 0, r equals 0. If r is greater than 255, r equals 255. Green, yes, oops. 1, 2, 3, 4. Red to blue, 1, 2, 3, 4. And if we're clamping, there's no way we can get invalid input, so it should be fine. Okay. All right, let's run this script just to see what it looks like. So go over here, come up to this thing, and boom. We're gonna get 3 books of different colors. Oh no, of course not. Color is not defined. All right. That should be easy to fix. It should be colors. And then run it again. What? I mean, colors is not defined. Oh, styles. Oh. Oh. Okay. So it's styles, and here's the thing. So styles sub light C equals stroke width and fill of HSL RGB of this thing. I think. All right. Mid C, mid brightness. Dark C, dark brightness. Okay. Oops. Okay, we're close, I think. Okay. Oh. Unexpected indent. Okay. That shouldn't be too hard to fix either. File format equals. Light C. Mid and dark. Oops. Okay. Unterminated string literal. Okay. Okay. Boom. There you go. Random colors. They are hideous, but they are random. Cool. Cool. Now do it again. Oh, that's because we ran the script. So, that is pretty hideous. But we don't care about that right now. Okay. I think this all goes away. Oh. Shelf height. I don't actually want the shelf height, I want the shelf width. Um, X offset. So we're going to change it to description. Let's go to Emacs mode since we're mostly in scripting mode right now. So we're going to start with X offset of that, index of that. Now what we're going to do is we're going to say book width equals 1 while book width is greater than 0. X offset, write a random book, increment that. Book width plus equals X offset plus equals book width. Okay. Total book width equals that. If book width is greater than self dot shelf width, return 0 and don't do anything else. Or -1, or something. It doesn't really matter as long as it's sufficiently good to go. So we're just gonna keep adding books until we run out of room. That's plan number 1. Oops, that's gonna. Okay. Book width. If book width plus X offset. There we go. There we go. Now when we run it, shelf height is not defined. Oh, we do need shelf height. Where did we write that? We wrote it there. Boom. Now, in theory, these books should fit on one of our bookshelves. They are very colorful, my goodness. Whew, yeah, we're going to dial those down a little bit, color-wise. We have a good variety of books. They're staggered. We could maybe make that staggering a little bit bigger. Oops. Let's do that. Let's make that just a little bit more staggering. Book offset 8. Okay. All right, there's a bunch of books. Yeah. Yeah, that looks okay at a large enough scale. One question we want is we don't want the previous or the next book to have similar hues. Because we've got like this green on green and this pale blue on pale blue. So maybe we need to keep track of our last hue and regenerate if we need to. I think so. All right, so let's go do that. All right, layout. Write a random book. The last hue. Does Python have static keyword for this that I can use the same way I normally would? On static variable in function. Okay, so I think we can do this. We say self overwrite random book dot last hue equals, I want an invalid number, 720 negative. While hue minus function dot last hue it's less than some number, 15. Let's say 30 degrees. If only there was a do while. Only there was a do while in Python. I wouldn't have to have this extra line out here. But no, they refuse to do it. They just refuse. Okay, so we're going to keep trying to grab a new one until we get the old one. Then finally, we store this hue as our last hue once we got one. Right now. Oh, of course. First, going to make sure the hues are a certain amount apart. Method has no attribute. But I'm going to put one in. Huh. Okay, fine. I'll stop being clever. So, self.last you. 720. I'll make a whole class thing just tracking this one call. Now the hues adjacent to each other are not the same at all. These are wicked bright though. Ooh, man. Should we tone that down a little bit before we do our last test here? Those were kind of hideous. To do randomize colors. That is done. Why do I have to clamp? The key indicates the outputs should be 0 to 1 inclusive. I shouldn't have to clamp. Figure out the problem. There we go. Okay. So when we generate our brightness, all right, we're not generating good amounts of books. Boom. That's a little better. Some light, some dark. There's a lot of blues and greens in here. Yikes. Okay, so we're going to put in the export image. Right there. Um, oh, I guess we just put one in for now. My color expertise. Primary colors are 1, 2, 3, red, yellow, blue. Exactly. Travest, thanks for dropping in. Always appreciate you having you in the chat. You get some good sleep. We'll see you tomorrow. Yeah, I always tell my wife I only know 10 colors. Your primary colors, your secondary colors, and then black, gray, white, and brown. That's it. That's all I got. Then she asked me hard questions anyways, like which shade of salmon pink over here goes best with this cupcake? I'm like, I don't know. I don't know. I don't even know what that word is. Interestingly, in foreign languages, or whatever your definition of foreign is, there aren't consistent color naming patterns. For example, in English, light pale red is called pink, but we don't have a special word for other light pale colors. Meanwhile, I forget which language, but there's languages where there is a specific special word just for light pale blue, but there's no pink equivalency. So interesting. Which words a language chooses to distinguish a color from another. While I think about this. So for each bookshelf, well, let's see. I'm not sure I actually need to do anything here. Let's put it back just in case we change our mind. Just in case. I think we don't need all these widths and heights that we're computing everywhere. Or that we're hard coding in. I think we can get it from the images. Okay. Let's just try it, shall we? We run it. Should take longer because it's saving out an image. We have an image for a bookshelf. Okay. Now, into Gimp, let's put our first bookshelf row in here. At 1350. Don't need these rulers anymore. Okay, and then this one's only needed for lining these up. So, where is the thing? We need our book set in here. Oh, am I sharing the? Okay, let me go share the right thing. Let me. Okay. So there's our bookshelf. Put it over here. Still some very bright books. We might want an exclusion zone around reds or pinks, or require greater a lesser likelihood of hitting those bright colors. It's okay. This is just for testing and layout. So we've got it at 0 and 1350. All right, so we're gonna save this, export. Then it's back to good old Emacs. UV rectangle. This will be a book set 1. 0. I said it was at 1350. the width and height. I did not write down, so that's very clever of me. Okay. Cheat layer, scale. It's right now 424, 104. 424, 104. Should we generate like 3 of these? Now that we're here, we might as well, right? We're gonna need a bunch eventually anyway. So let's go back to this view. Generate a new set of instructions for this thing. Delete, run it. Okay. So we're gonna need these numbers in here. Okay. Into Gimp 450. Yeah. Drag in the new book set. We're gonna make this slightly fancier as we go, but let's just get 2 or 3 of these bad boys in here. Let's do 4 just to 1475. Okay. This one was at 450. Three, 4. This happens at 1475. I do not know the width or the height yet. Okay, so we're gonna run our script. Okay. Okay. Got the yellow on that edge. Okay. Run it again, and then this again. Okay. Nice, nice. Import in the last set of books. Oops. I did not mark down the size, so layer scale layer. This tells me that it's 430 by 109. Okay, so this setup, export, everything else can happen inside of Emix. So, good, there we go. All right, so we've now got 4 book sets in there. The embed PNGs. What? Where are we? What is this? Oh, CD tools bin. Then run our image embedding. Okay. Oh, good. So our sandbox scene is going to need some boxes. Book sets. Book sets. Now that was scene elements 1. Hmm. Quad book set equals this thing. Set texture to the texture out of the image warehouse. Asset scene element 1. Set UV basically this. Book set 1 plus the index. Instead of cast it out. Okay. Now the one thing we don't have is the book XY coordinates. Hmm. Positioning the book sets. Okay. we also need to render our book sets. And this is the silly part. We're going to go past the bookshelf. Dot render. Okay, last thing, book set rectangle. We just have to know where to put the books. Okay. Ah. So we want to book set X equals something, book set Y is something else. Now, got the shelf X at offset. Plus half the shelf width divided by 2. Hmm. Plus, oh, hold on. Shelf wall thickness tells me how far in to come off that left edge. Y this shelf Y plus shelf extrude height. So that puts me at the top of the shelf. It puts the top of my book at the top of the shelf. So I need to find the bottom of the shelf. I mean, I know what that value is, but hmm. Well, let's go get those shelf width and height things. You know where this is. Shelf opening width. Shelf opening height. Okay. Book set X offset. Shelf opening width. Do I have a shelf thickness? Nope, I need the shelf wall. Shelf. Shelf thickness. Yeah. Okay. Just 10. Output. Wow. From layout script. For all three of these. Oh, come on. My keyboard's starting to get old. It's not registering all the key hits. Okay, these ones we just grabbed. Okay. Book set Y offset equals shelf opening height plus shelf thickness. All right, so book set X, book set Y, book. I do need the size for each of these. So in the image warehouse, we can get UVs. Interesting. Can't get the UV bounding size very well. Oh, that shouldn't be hard to write though. Except that this will be blown away every time. So, in here, to do, consider putting a UV size function in image warehouse. It basically does the following. I'm going to float Apply UVs. To image warehouse. I said scene elements 1. And given our UV key. And all the floats. And the address of that float. Oops. We're skipping. Whatever. Just get it done. Image width. All right. Okay. So we get the width of our image. Get the height of our image. Apply UVs. Now, we do know that these are rectangularly laid out, so the width will be, we started at the top left corner. And then went clockwise. So U1 minus U0 which width times U1 minus U0 and height is the image height times V0. It doesn't change over until V2 to the other row. Okay, so now we have a width and a height for our book set. In theory. Okay, so this will put the top. Let's see, where are we? Um, so I'm reaching to the top of the bookshelf plus shelf top. Uh-oh. Do we not have the top? Oops. Wow, come back. Yeah, why are we not just in Emacs mode? We're playing in Emacs mostly at this point. Oh, we are in Emacs mode. What am I doing? How many screens open? Okay. I don't have the shelf top thickness. Okay. Then we will go get it. $25. Okay. So this should put the top of each book at the top of each shelf. If it all works as planned. We will see. And the sad part is once we get this book laid out the way we want, it's probably going to require that I then break the bookshelf and start all over again on that, which needed to be refactored anyways, but like we have to change our whole approach. Because drawing order matters in an isometric world. Which is easier to see than for me to explain. But it should be very clear after we get this laid out. Oh, let's see. Okay. So x plus index modulus 2 question mark. Then we have the book set x offset. Otherwise we add nothing. If index modulus 2 equals 1, then book set y plus equals book set y offset. All right, let's try that. Okay. Oops. Word sleuth. Here we go. Hey, there are books, and they are wrong. Cool, cool. They're upside down. Why are my books upside down? This edge looks correct. Oh, I bet I know one of the issues. here. Renderer. Scale width. Renderers. Scale height. Okay. Now the books are just about correct. Except they're completely upside down. Why are they upside down? Hmm. Hmm. This is why. No. Oh, well, we didn't build. Build it. There we go. There are some books. And if we scale way up, you can see that the well, what can you see? Good question. Hmm. The books are too low. The top of the book is not aligning with the top of the shelf. Like, this is the bottom of the shelf upon which these are supposed to be setting. This is the top. So these books are way too tall. If we change our settings back, yeah. So these books are not scaled to fit on the shelf. The width looks about right though, like, oh. Well, hold on a minute. The width actually does look right. Maybe we just need to move them up so this line fits on your shelf. So this is our Y, which puts us at the top of the shelf minus the extrudes at the top front edge, plus the shelf top thickness puts us at the top, plus a shelf opening. Oh wow, can't get my hands on the right keys here. Shelf opening height. So that says that our Y is at the bottom of the first shelf. Take our Y minus book set height. Let's try that. Okay. Okay. So now all of our books are front edge on the edge of the bookshelf. We want to do kind of similar to what we did with these blocks, where we have those inset by just a few pixels along that diagonal. We want to apply that same thing to these books. We actually want to draw the books in reverse order. We want to draw the top books first and then the lower books. No, other way around. Right now we're drawing them backwards, so where we render, we're gonna go from or minus. There we go. And now we want to move them in. So the letterbox had a small offset we were adding. Block rectangle. Block extrude height. I guess we just take that, right? So we add no. R.x shelf. What's R? Let's put this block rectangle in. Who's using that? Oh, set the block rectangle. Okay, then we what is this? Font Y spacing. Is letter tile spacing used? No. I'm not seeing the math that would make it simple for me to understand where the offset is at. Word horizontal spacing. Block spacing. why. Okay, I suspect we can do something like this. This is just a guess. Plus this, minus that. I think that will do the slide it in place. Kind of. I would say that we're probably gonna crash. It's not 4 minus. It's 3 minus. Okay, boom. All right, so there's our books. And this is where isometric draw order really matters. What we really want to do is have the left edge of this bookcase draw, and then this bottom plate, bottom section here. And then if we have a book, well, we only have bookshelves down to here. So we can actually render the whole bottom half of this in one shot. But once we hit this shelf, we draw the shelf, the left, the shelf, then the books, then these books, then the middle divider, then these books, then bottom shelf, then these books, then finally the last panel, and then the top. So that those books are properly on the shelf. That's the problem. That's why we have to break our bookshelf. But we have books that are laid out correctly. They look okay. They look, I mean, other than the fact that the bookshelf isn't, they're not on the bookshelf. This all looks pretty good. So we're going to save our work here. Now have randomized books on the bookshelf. The bookshelf doesn't properly cover them, so we will have to break the bookshelf into components to control the draw order. Get reset staged assets images book set. Restore, not reset. Oh my gosh. Streamer brain, restore. There we go. Init my gem. We now have books on the bookcase. Boom. Okay. When we come back, we're going to do the break the bookshelf. In the meantime, I think it's time for a snack run. I have jalapeno poppers again, so we're not missing that. Just a minute. Okay. So we must render the bookshelf differently. So let's do a little bit of thinking about that. I know. Okay, if I render left panel, bottom panel, not necessarily in that order, middle panel, right panel. So that's 1, 2, 3, 4 panels, and top panels, 5 panels plus 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's like 23 render calls. Now, I do know that the books will never extend below 1, 2, 3, 4, 5. So I can actually draw all the way up to here in a single draw call if I wanted to. But I'm not sure that the two pieces of logic would necessarily be a good thing. So I think we're just going to lay it out in 18 draw calls or 19 draw calls or something like that. I think that's what I got to do. Now, on the flip side, these 4 panels don't take up very much room. In fact, these 2 panels, yeah, these 5 panels we can lay out pretty efficiently. What else? And this will just be a single shelf. The back panel of the bookshelf, we can just use a color quad. So actually some of the goofiness around drawing these spaces just magically disappears and goes away. So I think that's where we're at. So we left, right, middle, top and bottom panels to lay out. And change the way we draw the bookshelf altogether. We could add more books to our collection while we're at it, since we do need to see all 10 that they render correctly. Or do we? Maybe we don't. So many options. So many options. This jalapeno popper is calling the name. Okay. I'm trying to think if there's anything I'm missing here in the way I'm approaching the problem. 1, 2, 3, 4, 5, 6. There will be 6 separate UVs for one bookshelf now. Okay, let's go tear up the bookcase. It's going to be rough. Here we go. I do like, actually, that note from Sandbox. That is a useful one. That here, putting a get UV size function in the image warehouse. Given the image asset and the UV key, I can compute out the size that will be rendered. So we should add that to our to-do. That's way too handy not to have. Put a get UV size function in image warehouse. See to-do comment in sandbox scene. Yeah, that's way too handy. A lot of these other widths and heights just would be computable instead of constants, right? Up here. Like a lot of these widths and heights are just like, yeah, I can look it up. Now this one we can't. This one we could. Same with these two, etc., etc. So let's go break the bookshelf all down. Okay. The bookshelf. All the numbers remain the same. This and this are useful. We are going to lay out using the new method, so size, height, width, those kind of don't matter anymore. A lot of that's going to go away. Actually, let's just comment out everything. In theory, we don't need to simulate the layout anymore. Okay. We're basically just starting over from scratch. Now, I think escape boilerplate. I'm just going to mark this off as being a separate chunk. What else do we need? This is the general gist of things here. We draw a rectangle. We don't really draw rectangles with regards to the bookshelf. It should be all itself. Export PNG. I want to export multiple things per run, which means the file name has to be something we can prefix or postfix suffix. Name equals name if suffix name plus equals underscore plus suffix. Anything else? So mostly it won't make a difference to anything unless we choose to do something with it. So in the case of the bookshelf, bottom panel, draw a cube. The colors. Shelf bottom. So it's front, top, side. Front is mid tone. This bottom panel will be mid, dark. Then this one doesn't matter. You know what? Let's put an air color in here. If I see it, I should be very sad. So like make it a nice magenta, right? Red, green, blue. Now our prediction is this. So this thing has an X and a Y, width, height, and depth. So the bottom panel is the full width minus the wall thicknesses. There are two walls. And that is all. That's the loop X and Y. Then we get a width. Self dot width height. No. Bottom thickness in pixels. Then we need the depth. Self dot. The shelf depth minus some amount. So I don't know how much, maybe the wall thickness or the shelf thickness? Okay. If we want the top panel, drawing a cube, the front panel is still mid, the top panel will be light, and the right panel can also be error, or the right face. The width will be the same. The bottom thickness, so this is top thickness, I believe, and the depth will be the full depth. Top. So there's the top and the bottom. And yeah, that error, the right side of those two panels should be hidden by the rightmost panel. So you should see that lovely magenta in the final layout. Mm. Okay. We're going to output a bunch of these all at once. Okay. Should we try for the left and right panels at the same? Well, let's just see what these two look like. Print x offset equals self dot width in pixels, or plus equals. It's just for testing, so we can see the two panels side by side. Okay. Tools dot slash layout dot by. We want the what's it called? Shelf. Oh, just shelf. Why would I be consistent? Yep, not text. 844. Oh. Object size, I think, goes away now. That, we don't need that, we don't do that, we just do this. Yeah, that's way easier. Okay. Oh, dot text. Doggone it. I. Okay. Okay. Let's just run it then and just see what we get. Go to Inkscape. Apply. Key error mid. Well, shoot. Mid-dark and mid-light. Unbelievable. Okay, well. Not very helpful, is it? Which was which? I have to map colors that I didn't have. Okay, so we first drew out the bookshelf body, which was mid-light. Oh geez, and this does things in different order, doesn't it? Front, top, right. Front, top, right. So front in this case is mid-light, light. And mid-light, mid-dark. Because the shelves themselves, or the, let's see here. The shelf left is dark. Shelf bottom is mid-dark. So mid-light, mid-dark, doesn't matter. Mid-light on front, light on top, doesn't matter. Okay. Okay, then in here, X offset is not defined. It's called that. Okay, so into ooh, oh, dang. Filters. What was it called? On extensions render. This one. And apply, and it breaks. Self is not defined online. Huh. Self is not defined. Oh. Okay, we have to interpolate that value in. We're so close. Wait, these jalapeno poppers were delicious. Okay. Surely. This time it just runs. Okay. We have two shelves. And if you look, the bottom shelf is narrower than the top shelf? No. Perfect. That's fine. Oddly. Oh no, that's fine. The back shelf is a little bit less deep in terms of this this edge here, because the top shelf goes all the way to the outer back panel, whereas this one goes to the inside of the back panel. So yeah, these both look about like I'd expect. Good. Boom, boom. I do have an experiment I want to run real quick. Let's go to temp. And I want to actually bottom panel dot. I think there's a delete I can use in here. So if we go to Inkscape script, did I save a resource for that? No. Oops. Reference. I'm pretty sure it's in my email as well if I need it. Extensions. It's called something. All right, I don't remember. Just give me a minute. It's somewhere here. Let me. I have a link somewhere. Find it here and main documentation. This is probably more what I need. So okay. So in theory, we should bookmark. Is this a bookmark? Okay, bookmark into resources. And this one. This is the one I really want right now. Bookmark resources done. Okay. Delete, remove. Quick reference guide. I want like delete or remove. Delete, remove, remove. Okay, so I can remove things. All right, so that's what we're gonna try. I want to do both down panel remove and just see if it's gone. Because we want to do that. We want to come over to here, run it, and the bottom panel did not show up. This is just the top panel, so I think it's working. Good. So we're gonna go to this thing, and this is basically only for debugging, so I can see things relative to each other. You know what? Debug equals true. If debug. Else, do that. Okay. Alright, now it's easier to read, I think. We write ourselves a helper function if we want. Def write and export cube. It will have a name. Oops. It will have front style, top style, and right style. And then it will have XY width, height, XY width, height, and depth. And it's basically this with all the specifics polished off. Okay, so modulus S, name. Modulus S, modulus S, modulus S. So we get 3 more off the end of this. We get the front style, top style, and right style. Instead of this, we get X, Y, width, height, and depth. Okay. If debug, we move things, otherwise. There. Now this all becomes clear. We should be able to write and export a cube named bottom panel with these options. And 0, 0. Width. Height. There we go. In theory, that should simplify to that. Right, export a cube, meaning top panel. Basically these, except slight difference of light. X, Y, width, height, oops. Depth. And all that goes away. There we go. Okay. Make sure this still cranks out okay. X, Y. Okay. Okay. Looks okay so far. So if we run it, there's the 2 panels. Perfect. Good enough. All right. So that done. Right, export another cube. We need the left panel, and we need 3 colors. The front is mid-light. But the dark side, the rest of the shelves, this one. So the left panel is just dark. The bottom is, okay, let's just go with dark as our right. And the top should be whatever. So mid-light, dark, and the top is whatever. 0, 0. The width of the left panel is self.wall thickness. The height is the height minus self.bottom thickness and the top thickness. Because this will sit on top of the bottom panel and below the top panel, so the height should be a little short. XY with height, the depth will be the full depth, so self.depth pixel. With that, we can just about lay out the right panel as well. The front is mid-light, the top is error, and that side I think is mid-dark. Wall thickness, the height is fine, the depth is fine. It's mostly just a color change, really. Okay, so we should be getting 4 cubes now. And none of them are the center, so we come over to escape and run it. And there's our bottom, top, left, and right panels. Not bad, not bad. So we just need that mid one. One thing we do have to do, right and export a cube. Is we have to reset these. Okay. Otherwise, these PNG exports will have the wrong sizes. Over by some amount. And there we go. So our layout should be a little bit more compact. Boom, perfect. I don't have to feel bad about wasting my screen space. Left right panel, so the mid panel top panel. Top panel needs to be wider. Can't lose that distance. Okay. The top panel has to be full width. These will sit outside the bottom plate, but outside the top thickness. Okay, so it'll be bottom panel, panels left, bottom. Okay, let's do the center panel. Front panel's easy. This one will have a top of error, that's fine. And then dark. Yeah, looks about right. Oh, this thing's depth is not, it's more like the bottom panel for depth. So the bottom panel has a depth minus the wall thickness. So will this one. Only the top. Oh, interesting. And right panels will have that. The left panel is going to come up short, running into that back panel. Perfect. Yes. Okay. Oh man. Now the shelf itself. Shelf that goes in between. So the idea is bottom, left, right, oh, for Pete's sake, okay, object to the back. This panel comes in between here, oh, which means it's too tall. Good thing we're laying this out. Object raise to top. Okay, so this needs to be shortened, and this needs the right color. Okay. That's why we test. So center is too tall. Okay. Then the top, so the right side of the right panel is mid-dark, and the top panel should be mid-dark there as well. Okay, so bottom panel. And this one. Object. All the way in the back. So it's going to go right about there. This one. This one. This sits on top. About like that. I can't tell if these are collinear. Where's there like a doesn't help me at all if I can't draw straight with the mouse. Um, line. Oops. So why is the center so much higher than the edges? Center divider is the height minus the bottom plus the top. Hmm. Height minus bottom. Oh, these are height minus top. The top sits on top of these. These sit on top of the bottom. No, they sit outside the bottom. Okay. Now we should be getting close. So this one lower to the bottom, this one raised to the top. Yeah, sure-ish. This one. Good enough. Whoa. This thing. Roughly there. Okay, now they look like they're the same height. There, something like that. Ish. Cool. Okay, now we just need a shelf. shelf itself. Shelf. So the front face is the same. The top face is the same as the bottom panel. You will never see that side of it. In theory. Okay. Shelf thickness. So we're taking the whole width of the thing minus the wall thickness on both sides and the shelf thickness in the middle. And we're going to divide all that by 2. This should be the same as our shelf opening, what do we call it? Width. In theory. Okay. All right. All our building blocks. Okay, so there's the bottom. Here's the right, brother. I know my right and my left. Trust me. We have a shelf somewhere in here. If we did our math right, we always do our math right, right? Let's see here. Object. So page down. Page down is what I want. There it is. And we just move this one here. Top on. This shelf width doesn't look right though. According to our calculation. Oh, that's where the computer width comes in. Okay. So everything's working except we have a little spacing issue, which is fine. Okay, I'm actually reasonably happy with where we are. So if we go to this thing, I'm ready to just about chuck most of this. Boom. Yeah. Now. Um. Okay, so the height is this. So width and height need to be calculated later. Equals the number of words times the size of a block in height plus the number of words times the amount of vertical spacings we put above each word plus the thickness of the bottom plate and the top plate. Number of shelves, yeah, so that looks about right. And width gets a similar treatment. ISO doesn't need to be computed that way anymore. So the number of columns of words, there's 2 of them, times the size that we compute from our actual block. Pass in a block, let's just take the default block. There we go. Because our width and our height are computed based on the block. Everything else, I think, is good. So let's run that. Um, 260 plus. There we go. Now when we lay it out, magic will occur, right? Everything will be the right size. You, oops, sent to the bottom. Okay. This one. Okay. This, well, shelf, which I kind of want 2 copies of, so let's see here. Duplicate, thank you. Okay. line these up vertically. There it is. Okay. What do we do? Page up. There we go. This one comes up a layer. Up a layer. Down a layer. Okay. And this thing needs to align there. Everything should just magically line up, right? Okay. Just make sure there's no pink showing. There. That is the basic idea of our bookshelf. There's like a 1 pixel off error here. And that could be, that looks okay. Looks like there's just 2 pixels off somewhere. Possibly due to rounding errors. So, there. I think we've got all of the elements of the bookshelf done. We'll use a color quad to draw the background color from there to there to there to there. Woof. Okay, so this is all super fun. Where are we at here? How are we doing? Anybody have any questions, comments, concerns? Making more tools? Well, not making more tools, more so just updating them as I find use cases that make sense. But the overall workflow, I think, is good. We're still exporting an Inkscape script, running it in Inkscape, and that exports our images for us, which we then pull into our asset pipeline. So overall, I think our tools are getting pretty mature. Bookshelf. Oh, there, math. It's not used by bookshelf. So we're going to move that to journal because we did that. We broke the bookshelf. As part of that, we did this. Okay. The bookshelf has been broken into its constituent parts. Left, center, right, top, bottom, panel. Yeah, so I'll show you what we're doing here in just a second. And shelves. As part of this effort, bookshelf was refactored to the new layout methods. Like all the other drawing elements. Okay. Relay out the bookshelf in sandbox with book on shelves. Okay, so that's kind of a big ask. Let's just run it real quick. So what we're trying to do, if we go into sandbox, we've got books on the shelf, but the books are being drawn on top of the shelf because our shelf is one draw call right now. It's one texture. So if we want the bookshelf to clip the tops of these books and these edges of the books, right? We have to draw this shelf. Well, we have to draw this left panel, we have to draw the bottom shelf, then the books, then the right panel, then the shelf above it, right? So we have to draw this shelf in multiple stages for these books to clip right behind the bookshelf in the right order. So we've just broken that up texture-wise. We got to redraw this whole thing. Right now we're still doing just the standard single bookshelf in one draw call. So fixing all that. Good times. Good times. Okay, so the good news is in layout math, because of that code, we no longer need this code, or this code, or that code. It all just goes away. Hooray, hooray. These shelf value updates, though, are going to be a little bit interesting. Might as well output this, right? Shelf width is width in pixels. We no longer need to compute it. It's done in the constructor. And the height. The extrude amounts are fine. The wall thickness, bottom thickness, word horizontal and vertical spacings. Is fine. But in sandbox, we did have some to-dos. We need the top thickness. So where we put out the bottom thickness. We need the top thickness as well. And then we need these values. Actually, it's here. Okay. So we need shelf thickness, shelf thickness. There we go. Opening width. And opening height. For different layout tasks, we kind of need slightly different numbers to get there. Sometimes we could compute it ourselves, but okay. Line this up. No. / layout Python. The what's the thing? Shelf output to temp.py. Equals false. So if we run this, it will output 6 different files. We will probably never see the image actually appear in Inkscape. We should have 6 new images showing up in our asset directory. Oh, let's see. I'm sharing the OBS. Play. All right. So I'm going to go. So it should be showing up if I've done this right. Is bookshelf bottom, center, left, right, shelf, and top. And we're done. And we have the sizes for all of them. Very nice. Not bad. Not bad at all. Maybe we use name in there. Let's just get that real quick. It'll be a good quality of life improvement. Export print image size of this thing, which is the name. Okay. Inkscape. Okay. Now we're gonna run it again from scratch. And we should get better output at the end of the run. Oh, running out of water. We've got an hour left. Hour left. We might have the bookshelf drawing correctly by then. Okay, we have a whole bunch of bookshelf items right there. Copy that. We're going to put it into the scratch buffer for later. Now comes the fun part. We need to lay out our whole this thing. We lay out this whole thing without so this book, this one can go away. This one needs to be hidden. We actually need a bring all these bookshelf things. So in theory, drag these all in, then we'll figure out how to pack them reasonably. A couple things we're gonna do. We're gonna new layer group. Call this one book sets. That way we can manipulate them as an entirety if we want, if they're getting crowded. Add another layer group called note. Oh, come on. Books for obvious reasons. Oops. Letter block, fine. Bookshelf. Okay. We're going to create a new layer group called bookshelf. Okay, now we just have to move everything to where it makes sense. So we're going to start with the right panel. Move active layer. So there's a good way to show hide grids by group as well. Like if I could put grid lines inside of a group, that would be super handy. Okay. So that's the left. That's the right. Right. Left is this one. Center divider. Then we want the, let's go left, center, right. Oops. Those are backwards. We want any kind of clarity here. Center divider. Right. There we go. We want to go left, right, top to bottom, every chance we get. The bottom panel, I want to do the top panel first. Oh, it doesn't fit with everything else. Perfect. Okay. Move this down some amount. Okay, now the bottom panel moves up somewhere. I don't know where. Which means these have to move down more. Which probably means we're running into other elements, but we should be able to shuffle things around without too much trouble. Right panel. Then finally the shelf. So there's our bookshelf. Not properly laid out, but partially laid out. Yep, we're running into things, the book sets, and the letter block. So we're gonna put these 4 notebooks over here. Yeah, the layout of everything's gonna change. Well, I wonder if I could write. Could I write a Gimp script that takes each visible layer and writes it out as a UV coordinates that I can use? Wouldn't I have to install an extension into Gimp, if I remember right? That would be super handy. It means I could lay things out, it would crank out some text, and I would just paste it into the images. That almost sounds worth it if we're doing a lot of this. Which actually we're kind of towards the end of the layout phase. Like a lot of our stuff is here and done. Maybe not done, but oh gosh, I don't know. Not sure how I feel about that. All right, let's do this. This thing is where it is and will not move. So, oops. I'm going to go back to picking a layer guide. So we're going to come down to 125. This one there. 235. 235, 235, 235. Ish. Okay. So we need a divider 90. A divider at 170. Sure. I don't know where all this stuff goes. Okay. We're not really being that efficient with our layout, right? We can pack a lot more stuff in if we had to, but leave that guideline alone. This, not this one. This guideline over to some normal number like 280. Um, or yeah, I'm like 9% towards writing a Gimp script that exports the visible layers. That sounds super handy. 435. That's really just an investment in the future, right? That's kind of how I want to see it. So this block can go here. We should put a guideline over here somewhere. That's basically where everything needs to be. Um, yeah, so many of these guidelines just are no longer useful. Do we want to do some Gimp scripting? Is that a thing we want to do? I kind of want to. Okay, so it's our texture. I kind of want to write a Gimp script, even if I don't know how. Could I fit? Hold on, I'm just looking at my layout here. Maybe I can. I can't make the height small enough. I don't know if that's true. What if we move? Nah, that's fine. So here's a question. Could I put these bookshelves over here? Is there enough room? No. All right, bookshelves are wide enough. Okay, now. I kind of want to write a Gimp script, but I don't want to write it in Scheme. I want to write it in Python. That way, my systems are more consistent. Okay. So let's take a look. Just a moment. Let's see. Can you do layers in Inkscape as well? Yes. I can do layer things in Inkscape. Um, it's more about, what's it more about? So far, I've preferred that Inkscape execute one image per thing. But what? If I can get the width and height of each object in there, I could make it export the PNG directly and not go through Gimp. And then it could write out the UV parameters for each one. Inkscape, Python, Foo, and Gimp seems like it could be useful as well. Yeah. I mean, we're already doing quite a bit in Inkscape. Maybe we just abandon Gimp altogether. Oh, no, we can't abandon Gimp altogether. There are some things that we hand draw that we can't vector draw or don't want to vector draw. I did the banner in Gimp, not in Inkscape. Does that argue for me redoing the banner in Inkscape? Maybe I'm just an Inkscape kind of guy. Oh, okay. Well, hold on. Here's the other thing. This is only for layout. Has nothing to do with our final art, which will all be scanned in. So I think importing layers into Gimp from scans and having the UV coordinates be the same is probably better than building too much functionality into Inkscape. Maybe. Okay. Let's go see what it takes to get Python foo into Gimp. I don't think it's a, let's see here, Python foo Gimp. They may require me to update my Gimp. I try not to do it. Console. So in the console I can just do things. Blah blah blah. Console button, save, clear, browse, image, thing, new. Use the console to find a description. I mean, it's just Python. It's not like it's rocket science, right? We've got 45-ish minutes, an hour left. Let's just go start playing with Gimp. We're gonna modify our to-do list. That's what we're doing. We are doing it. So in our journal, start writing a Gimp Python foo script to export to write out our UV info from layer data. I don't think we'll get done with that today, and we'll probably not get to any of this other stuff today, but that will be one more cool tool in our pipeline. So let's save our work where we are. Bookshelf parts have been generated and added to the scene elements file. However, the entire UV data have to be recomputed. I will be writing a Gimp script for that. So we can arbitrarily modify our images and still get the UV data easy. Seems good. Status. Okay, so we're gonna add assets, images, layout scene elements 1. Git add doc journal to do tools layout math. We don't need to add any of those. Okay. Bookshelf is laid out in Gimp. To update UVs before rebuilding the bookshelf in Sandbox. Okay. Gimp scripting. A whole new world. I'm using Gimp. Yeah, I did come in with it. I guess I was thinking of Inkscape. Inkscape, I had to install the plugin. Gimp, it just came with it. So, yeah, for vector drawings and for laying out pixel perfect art, the vector drawings make sense to me. Anything more artistic, and I'd have to be a lot more artistic to actually do anything in Inkscape. It's super powerful. I've seen some crazy cool stuff, but I'm not there. Yeah. So okay, Python foo. I guess where to begin. So let's put this window on top of Gimp. We're gonna close Inkscape for now, I think. If I can. Close Inkscape. Don't save. I can always regenerate, and then we don't really need that window open. So I think Gimp and browser. So let me go to here. Boom. Okay. Python foo. So where's all the documentation? One click the procedure browser. Browse. Apply. Okay, so save in Gimp. Python foo console. Where is it? There it is. There's a help, there's a browse. The browse brings up a bunch of stuff. I want to see like layer list layers. These layers, get layer by name. That will be a thing. Get layers. Get image. Get layers. Parameters image. What's the current image? Let's see here. Image. Buff. Get image type. Get. I wanted like the current. Current. What's the active image? Is there like a get active image? Get active drawable. Right. Gimp Python who get image in current tab. There's got to be a way to do this. How to refer to the active image? That sounds simple enough. On interactive. First primary script is an image. Okay, wonderful. Oh, PF image. And it is assumed to be the current image. Okay. All right. Thank you. Image is not defined. Really? Did I misread that? Print PF image is not defined. This person is using the scheme foo. Do I just say image? See, this whole document seems like it's either out of date or yeah, this person, like, this should not be so hard. What's going on here? Image members, image methods, channel objects, layer methods, drawable objects, drawable methods, tiles, pixel regions. Yeah, see? Python. An example. There we go. Learn by examples. Sure, I guess we can do all that. Image equals, so that creates a new image. I have to do this. PF image. Huh. I'd like to just get the image. Image object. Represents an open image. Generic image object. Sure. Sure. That would be lovely. I would love it if I could. Oh, for Pete's sake. Why is this so hard? Image equals. I think this creates a new image. That's what I think. I don't want to create a new image. I want the active image in the thing. Why is documentation and example so bad? You pass an image object. Image list. Image at index 0 is the rightmost. Okay, so maybe this is what I need. Gimp.image list. Okay. So what's in an image? We were just looking at that. Image object. Active layer. This is the active layer. I want to know if the image itself is active. Maybe Gimp. Active image. That'd be consistent with their naming scheme so far, but no. File name, height, file selection layers, selection width. What? How am I supposed to know which image is the active image? Gimp module procedures. There we go. That creates an image. Yeah, exactly. Layer, channel, display, window. Don't care. Parasite. Configuration information palette. Operations gradient. Other functions. Query images. I suspect we can do what we need to, but alright, well, let's do this. Let's get our image list. Let's get an image. Equals this thing. I don't really care. Image dot, let's see here. Surely they have proper doc strings, right? Okay. Hello, Python. Which Python is this? Good heavens. Doc. There is none. Okay, what if we do this? What if we do it by class? Which class? No doc string. Wow. Name. Okay, we have an image. We don't have a doc string. There used to be a thing. So member for member ender if active in M. Active channel, active drawable, active layer, active vectors, get component active, set component active. Okay, so maybe image dot get component active. Huh. Why? Why Gimp? All right, well, whatever. We're gonna get images by tab, I guess. By active channel, active layer. Like I understand sometimes you want to work with the images independent of what tabs, and even if it's showing, that's fine. But can't I get the active image? Why is that so hard? Why is it so hard? JTL. Export layers cumulative. Of course. All right. Extract. Oops. There we go. Extract all here. All right. Let's bring it up. If register, export, blah, 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 show layers. All right, let's show layers for every layer in the list of layers. Export layers cumulative. If it's linked and visible, reverse them, sure. Hide the layers. Image. Nope. Okay, so the short answer is I have to when you run a script from this sort of environment where we've registered it. Yeah. So this says get the active image, but I can't query the active image from the code itself in a console. Okay. All right. So we're gonna do all this later. Okay. I guess that's what we needed, sort of. An image object. Layers. We found that in the browse, right? Layers. Gimp image get layers. Oh. It doesn't know what image is, so there we go. Now, oh, none of my keyboard shortcuts work here. It is not Emaxified. I think I saw this thread. Yeah, if your code is correctly written, blah, 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 it's part of the active registration and activation. But the drawable, yeah, yeah. Yeah, it says basically the same thing. You have to register correctly to get the active image. There's no way to query it scriptedly. Okay, that's fine. We'll figure it out. We'll do it the way they want. Okay, so... Oh, dang it. Python foo console. Where'd it go? There it is. So... And it doesn't remember anything we just did. So... arg... image, we'll just grab the image, doesn't matter. Then layers. Okay, then layer IDs equals active, what's here? Get layer is act visible. Get image layer get visible. So L for L in layer IDs if Gimp dot that is not what I wanted. Thank you. Okay, it does not remember. L for L in layer IDs if edb dot Gimp get layer get visible. EDB. So those are the layer IDs. Okay. Now, that's with respect to these visible layers. So one thing I have to ask is, so there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 in theory. Oh, no. Let's get image 1. I think we're looking at 1. Now we get our layer IDs. 1, 2, 3, 4, 5. So those are the groups. Okay. So I think we can start working with this. Yeah, I think this is doable. How much time do we have? We don't have a lot of time. So I'm not sure I can resize this in a meaningful way that you can see better. Okay. This, I think, is the core of it. Is layer a group? That would be nice to know. Gimp image. I want the layers. Layer objects, members and methods. Layer, is there like a group thing? Group. Oh, for Pete's sake, fine. Browse. Group. Undo group. Item is group. Gimp item is group. 431. It's not going to be. Not going to work. I just want the layer. I want the layer object. Get layers. I have remove layer. Item is layer. Delete, flatten. Can I not get the layer itself? Get layer new. From visible. Scale. A lot of these are useful eventually, but mode name. That's set name. I'd like to get the name. Color, font. I don't care about text layers. I want to get the layer object. Maybe it goes back to this one. Image dot layers. So maybe I just don't need this. Layers equals image dot layers. L for L in layers. If layer dot visible. Oh, L is visible. So I have actual layer objects now. Wonderful. Okay. L equals layers 0. L dot this here, not that. No, not that. Okay, we're gonna look at all the things available on a layer, and we want entry for entry in that listing if group in that element. Nothing. How can I know if children? Mask. Maybe children. If length of this one, layer dot children. Yes, thank you. Oh. Children linked. Parent. Scale transform. Why can't I see update visible width? Type. Maybe type. L dot type 1. L dot type or L in layers if L dot visible. 1 1 1 1 1. So that's there's no difference between those. How do I know if it's a group? And if it's a group, it's all right. I'm group. Nothing in there. Group. Nothing in there. Gimp Python foo is a layer, a group. That doesn't help. Nested group layers. Thank you. Gimp layer group. That creates one. Insert image layer. I don't want to create one. I want to run through them. There is extreme API asymmetry in which you could add layers and groups through the add layer method, but you have to either enter layer group, the bug for group layer. Necessarily add, but at least they're answering a little bit. Layer groups. And none of this. Is talked about in terms of Well, I am not terribly impressed with Gimp's documentation or API consistency yet. This is not how I want to interact with Gimp. Okay. Mask, parasite, BPP, children. If it was a group, I'd expect it to have children. So maybe we do this. Let's do for L dot length of children. No. Length of L dot children. Yeah, they're all empty. So it tells me there are 5 layers which are visible. 1, 2, 3, 4, 5. I agree. 3 of which are groups. Mode was useless if I remember right. L dot mode 28. So that doesn't help me at all. I would expect 3 of them to be different from the other 2. Is gray, is indexed, is floating selection, image height, has alpha, title. There's nothing in here about group. Merge, shadow, mode, name, offsets, parasite, attach, detach, find list parent. Mask resize, scale set offsets, show mask tattoo, transform. Like some of this. Huh. I don't. Group. Gimp item is group. Group new. See, this creates a new layer group. I have one. I want to ask you. So let's try that. Let's go. Gimp. Item is group of L. Oh, for Pete's sake. A layer for layer in layers. None of them are groups. Turns truth specified item is a group which can have children. None of the layers. What if I hide some of these? You get my layers. Let's see, where's it? Layers. Those are layers. So if we do this line again, I would expect 2. Oh. Oops. Oh. What? It returned 5 layers again. Well, there's a lot more than 5 layers visible here. 1, 2, 3, 4. 4. That's at least 8. So change our image. Let's get a different image. Let's get the 0th image. Get our layers equals image layers. Zero. Oh, hell no. I don't care about that. Okay, so this has the book sets, notebooks, letter block, group layer, and a background. Dot children length. Maybe I'm just in the wrong place here. Okay, so let's have children. I must be looking at the wrong image. So let's take some notes somewhere, just as a way to get this one, and then this seems to work. Oops. Okay. All right, so I think we know enough to iterate through, get the layers, L dot width, L dot height. Is this giving me an XY? Dot position, dot pose. Wow, okay. Get layer position, that would be layer, mask, bytes per pixel, edit mask height, image, is floating selection mask, mode, name, opacity. So layer name is going to be useful. We're going to love that line. Okay. But I don't have a position. Position, X, Y, pose, anything of that sort. Parasite, parent. Transform 2D. 2D. It's a built-in method. What is the transform matrix? Can I get its position? Everything about transform is rotate, simple. This is going to be a method. Yeah. So where do I get my actual position here, people? Wow. Gimp, Python, who, get layer position. Relative to the image. That would be nice. It's layer.offsets. Oh, wow. Oh my gosh. Wow. Okay. But with that, I think we have everything we need. Yeah. Yeah. There's all the offsets. Although, oops. That does raise a question. Bookshelf and background are at 0, 0. Well, that's fine. Because bookshelf, background I don't care about. Bookshelf. So we have book sets, notebooks, letter block, bookshelf, background. I don't care about background. Okay. So this one being 0, 0, 0 at bookshelf is fine. Okay. All right. So offsets. Like I would like to work with this a little bit more interactively, but I think this is enough. If I have an image, which we'll get by setting up the script, right? The layers we can get, then we can walk through and say if they're visible. We can walk through the children and get the name and the offset and the width and the height. So we can do width. Oops. Width and height. Yeah. That's basically everything we will need. That's it. For our most common use cases. Okay. That's everything I need. Their interactive experience with scripting is pretty much garbage, but I've got 15 minutes, but I know every method I need now. In theory. So, let's see, word sleuth tools. Gimp. Let's see here. Export Gimp UVs. Python. No, we're going to steal from the example, wherever that was. This example here. This example, we're going to import this thing, which is probably in the documentation somewhere. In other words, like an example somewhere. Example plugin. Gimp foo, yeah, sure we can do that. this one. Alright, let's grab both of these. Still both best of both worlds here. Kind of don't care. Main. Okay. This one has a registration. Author. The Doe, year 2024. Export menu. Image. File export. Export. UV. Mapping. Register. Within. Doe export UV from layers. Export description plus tilde, I guess. I'm not sure why they would do that, but okay. Star PF image is image input image none. Directory name fine. String name pattern file name image name. Can I write it out to console? That would be way better, but that's fine. Okay, so that's registration. Now, journal. In theory, we have an image. This thing assumes that we had an image here. Directory name pattern. Don't really need that, do I? Okay. So we just do that. Name and directory. Print some stuff, I guess. So the image has a name. PF string. Okay, so we need to know the out name, the file name, which is a default, I guess. Input image directory. Let's see. the input image, output image name. Output name. Defaults to image name, I guess. Okay. Directory. Out directory. Output directory. Asset directory. Dot slash. So basically, this is our out name. This should be this. In theory, export image and UVs. Okay. Ping and image and UVs. All right, let's see what happens. Let's just try this out and see. Oh wait, where do we go? Okay. So we got image, out directory, out name, asset directory. Image. Let's just see if we get anything. All right. Windows. Let's see. I probably have to drop this in a particular directory for Gimp to get it. Plugin framework. The Gimp food module is introduced. Name, verb, help, etc. PF things. Parameter list holds a list of parameters for the function. Yes. Structure of a plugin. Auto manuals is an example. Import modules. Plugin framework. So where do I get my plugin? Gimp. How to add my Python plugin. Surely. Installing Python scripts. Filters, console, print gimp.directory. That sounds like it might be a useful thing to know. No. Just run it. Cancel. Okay. Copy, what was it called? What did I call it? cp export Gimp UVs to this directory. And then, oh, plugins subdirectory. Doggone it. Okay. It's all right. See, users, the doe, app data, roaming, Gimp, 210. Plugins. Okay. So we're going to copy this into plugins. So back into here. Plugins. There we go. Okay. Restart Gimp. Of course I have to restart Gimp. Everything press reboot these days. Why? Oh, let's see here. Fine. It's a Python script. Can't you kill it and restart it or something? Detect a file change by the file system? Ugh. Oh well. So in theory, don't remember where I put that. Image file export. Menu. Okay. Come on. Image filters. Artistic clothify file. Export. Oh, here it is. Export. Click. What happens? Okay, so I've got an output directory. That's not helpful, but it's okay. And that asset directory is fine. Does anything pop up? I don't get any console output at all. Okay, good to know. So this thing gives this. That's okay. Fine, I guess. All right. Import OS. Let's see here. One other question. Yep. Python foo output. Kind of like read. Editing and storing. Oh, good heavens. Print. Log. Do I have to write my outputs to a file? Python foo output. Example. Blah blah blah. Print. Um. This all looks very old. This is like Python 2.6 or maybe 7. And so when I ran it, I didn't get anything on the output. So file, export. Okay. Where's my output? Where's my output? Dockable dialogues. Console? Yeah, I'm not getting anything. Okay, well, we know enough, I think, to do the job. So we're gonna call it there for the day. And yeah, I think this will be a big time saver, especially as we go from project to project, multiple projects. Is there not a way to import and run a separate script file? Yeah, like Inkscape. I was literally able to type in whatever I wanted into a box and it worked the same. Or I could have it in a file, which I could have just loaded up. But no, Gimp requires it to be loaded as a plugin. Yeah. Have a good night. Thanks. And yeah, tomorrow we'll get that Gimp script done. It's not hard. It's just their documentation sucks. So yeah, thanks. Have a wonderful evening, and we'll see you tomorrow. Bye bye, everybody.